Space rocks carry secrets from the birth of our solar system to Earth. These cosmic time capsules hold clues about life's origins, ancient water, and even possible alien traces. Let's explore what these celestial messengers can teach us. Let's look at one of the most amazing meteorites ever found, the Allende meteorite. This space rock crashed into Mexico in 1969, and it's older than Earth itself. When scientists studied its black chunks, they found tiny white spots called calcium-aluminum inclusions. These spots formed about 4.6 billion years ago, making them the oldest known matter in our solar system. Think of the Allende meteorite as a frozen snapshot of when our cosmic neighborhood was just taking shape. It contains bits of stardust, strange minerals, and even traces of organic compounds that might tell us about how life's building blocks first formed. What makes this meteorite extra special is that it landed right when we had the technology to study it properly. When scientists examine meteorites like Allende, they often find something amazing: organic compounds, the basic building blocks of life. These space rocks contain carbon-rich molecules, amino acids, and other chemicals that are essential for living things. It's mind-blowing to think that the same ingredients that make up our bodies were floating around in space billions of years ago. These compounds might have hitched a ride on meteorites that bombarded early Earth, bringing the raw materials needed for life to begin. The famous Murchison meteorite, which fell in Australia in 1969, contains over 100 different amino acids, the same stuff that makes up our proteins. By studying these cosmic chemistry sets, scientists are piecing together how life's ingredients first came together on our planet. One of the biggest surprises in meteorite research was finding water locked inside these space rocks. Some meteorites contain minerals that could only form in the presence of water, while others have actual water trapped in tiny pockets. The Monahans meteorite, which landed in Texas in 1998, had salt crystals with droplets of ancient water inside them. This water is about 4.6 billion years old, older than our oceans. Scientists think these water-rich meteorites might explain how Earth got its water in the first place. Imagine countless meteorites raining down on early Earth, each carrying tiny amounts of water that eventually filled our oceans. These space rocks also tell us that water, which is crucial for life as we know it, is more common in space than we once thought. Now let's talk about one of the most debated meteorites in history, the Orgueil meteorite that fell in France in 1864. Some people claimed it showed signs of alien life, with tiny structures that looked like fossilized organisms. When it first landed, scientists found carbon compounds and what appeared to be organized structures inside it. This sparked wild theories about extraterrestrial life. However, careful research showed these fossils were likely Earth contaminants or mineral formations that just happened to look biological. While the Orgueil meteorite didn't prove alien life exists, it taught us valuable lessons about being careful with extraordinary claims and the importance of thorough scientific testing. It's still studied today for its rich chemical makeup and what it tells us about the early solar system. When we look inside meteorites with powerful microscopes, their crystals tell amazing stories about their wild rides through space. These space rocks experience extreme conditions, getting super hot, freezing cold, and taking powerful hits from other objects. Each of these events leaves a distinct mark in the crystal patterns. It's like reading a travel diary written in the rock itself. Some crystals show shock patterns from massive impacts, while others have melted and reformed multiple times. Scientists can even figure out how fast the meteorite cooled by looking at the size and shape of its crystals. Large, well-formed crystals mean slow cooling, while tiny crystals suggest the rock cooled quickly. These crystal patterns also help us understand the harsh conditions in space and what happens during a meteorite's fiery trip through Earth's atmosphere. Back in 1996, NASA made a huge announcement about a Martian meteorite called ALH 4001 that shook the scientific world. This space rock, found in Antarctica, contained tiny structures that looked surprisingly like fossilized bacteria. The meteorite was blasted off Mars by an ancient impact and spent millions of years traveling through space before landing on Earth. Scientists found microscopic tube-shaped structures, magnetic crystals similar to those made by Earth bacteria, and carbon compounds that could be signs of ancient life. While many researchers now think these features probably formed through natural chemical processes rather than living organisms, this discovery kicked off a new era of Mars exploration and showed us how we might identify signs of life beyond Earth. Let's explore how scientists use meteorites as cosmic clocks. Inside these space rocks are tiny amounts of radioactive elements that slowly change into other elements over time. It works like a countdown timer. Scientists measure how much of the original element is left compared to what it changed into. This tells us exactly how old the meteorite is. Take uranium, for example. It changes into lead at such a steady rate that we can use it to date rocks that are billions of years old. The really cool part? Different radioactive elements decay at different speeds, so scientists can cross-check their dates using multiple timers. This is how we know our solar system is about 4.6 billion years old. These space rocks are like nature's stopwatches, helping us understand when major events happened in our cosmic history. Some meteorites bring us an amazing surprise. Real diamonds from space. These aren't like the diamonds we find on Earth. Space diamonds formed when carbon-rich meteorites experienced powerful impacts or intense pressure in space. When scientists cut into these meteorites, they find tiny diamonds, some smaller than a human hair. These space gems tell us about massive collisions between asteroids and the extreme conditions in our early solar system. Some of these diamonds even contain trapped gases and minerals from the time when our solar system was just forming. The Almahata-Sitta meteorite, which landed in Sudan in 2008, had diamonds that formed inside a lost planet that was destroyed billions of years ago. Let's explore one of space history's biggest mysteries, the Tunguska event of 1908. On a summer morning in Siberia, something massive exploded in the sky with the force of 1,000 atomic bombs, flattening 80 million trees across 830 square miles. The blast was so powerful it lit up the night sky as far as London. While some people jumped to conclusions about alien spaceships, scientists found a more likely explanation: a large meteor or comet exploding in the atmosphere. The interesting part? No major crater was ever found. This tells us the object likely broke apart before hitting the ground, creating an airburst explosion. The Tunguska event teaches us how Earth's atmosphere protects us by breaking up many incoming space rocks. Modern technology is helping us unlock amazing new details about meteorites that we couldn't see before. Powerful electron microscopes now let us look at space rocks atom by atom, revealing hidden crystals and ancient molecules. Special machines called mass spectrometers can identify exact chemical recipes from tiny meteorite samples, telling us what elements were present when our solar system formed. 3D scanning creates detailed maps of meteorites' insides without cutting them open, showing bubbles of ancient gas and hidden cracks from space collisions. Scientists are even finding new organic compounds that could help explain how life began on Earth. Each new tool we develop helps us read these cosmic history books better, turning space rocks into windows to our past. Thanks for joining me on this cosmic journey through the mysteries of meteorites. They're amazing time capsules that keep teaching us new things about space. If you enjoyed learning about these space rocks, hit like, subscribe, and share with your fellow space enthusiasts.